Today I am going to solve the physics problem. This is NEET 2025, which was currently held. So I am going to solve all the problems, but this will be in phase wise. Here you see that we have to find the potential difference between A and B. We have to find the potential. So I have considered here you see, I am consider this here a point C. You see the black dot. Here I am going to consider the point C. So here you this VC minus VA, VC minus VA, this is equal to, because this is self inductance, minus L di by dt, and here you see that the value of L, it is given to you, that is in the figure, that is it is given to you, minus 1 into di by dt, it is also given to you, that is 1. So this comes out to be minus 1 volt. Now again I am going to find the potential difference between this VC and VB. Your potential difference between VC minus VB, that will be equal to epsilon plus I. R is the internal resistance. So your epsilon is given to you 5, and current I flowing through it is 2, and the internal resistance is 2. So this comes out to be 9 volt. Now here you see that VA minus VC, this will be equal to 1 volt, and your VC minus VB, this will comes out to your 9 volt. So here you will get the total voltage, that is the difference VA minus VB, that is equal to 10 volt. So this is your answer. Now I am going to the second question. Here I am going to your this second question. I have to click the second question. Then I am going to click this second question. Here you see the second question. We all know that a current carrying loop is a magnetic dipole, and its magnetic moment, we know that the magnetic moment, that is equal to N I and the area of the loop. So here we are going to find the ratio. So this is M1 minus divided by M2, that is equal to, your I current is constant in both the coil, so only the difference in area, so it will be pi R1 square by pi R2 square. So this will come out to be R1 by R2 the whole square. So this will come out to be 1 by 2 the whole square, and this will be equal to 1 by 4. This will be 1:4. So this is your answer. Now I am going to the third question. I have to click the third question. See, third question. This is your third question. Now here your third question, if you see minutely, you will find that the 5 by 2.5, that is equal to 2, and again 3 divided by 1.5, that is equal to 2. So it is a Wheatstone bridge, and the current through the 6 ohm resistance is 0. So now you will, when it is 0, so here you see that B across B, the total resistance across B and E, because these two are in series and these two are in series, and they together combines to form a parallel connection. So here your equivalent resistance across BE, it comes out to be 8 by 3, and all these are in series, 1.5 plus 5.5 and plus 1 by 3. So this comes out to be, if you calculate it, this comes out to be 10 ohms. This is the equivalent resistance. So the current flowing through it will be I is equal to your V, that is 5 by 10. So this is equal to 0.5 ampere. So this is your answer. Now I am going to this third question. So I am going to this the third question. Here you see your third question. In this, again you see that a string with some mass n, it is rotated, and now here we have considered point P. You can see in the picture the point P. You can see in the picture the point P. So here this mg sine theta, this is your centripetal force. So here you can, this is mg sine theta, this is your centripetal force, that is mv square by r, it is the length of the string. So this comes out to be your final, this v velocity, this comes out to be root g L sine theta. This comes out to be root g sine theta. This L, this is the L, you can consider this as L, small letter L. So this is the velocity where at point P. Now we are using the conservation of energy. By using the conservation of energy, and let the velocity here be V naught, here this is only kinetic energy. If we are using the conservation of energy, so this will be half m v naught square, and this is equal to half m v square. This is at point P, plus the potential energy, that is mg bracket your L plus L sine theta. This. Now I am not going to calculate all this in details, but if you calculate this, if you calculate it, you will get, that is if you calculate it, you will get, that is V naught. You are going to get V naught square, that is equal to 3 by 2 GL sine theta plus your mg L, mg. Now from here you can see that your GL, 1 minute here, this will be GL, not L, M will be removed here. This will be G, this will be GL, this will be GL. Now, and this 2, because half cancel out, so this 2 will be also cancel out. It will be, so here you will get that V naught square, that is equal to GL, this is common, so GL common, that is 3, you are going to get 3 sine theta, and here, because we are going to take here LCM, so here there will be 2, the 2 will be here, so 1 plus 2, because here you are going to take the LCM. When you take the LCM, here this 2 will come out, so your V naught, that will be equal to root over GL bracket 3 sine theta plus 2. This will be your V naught. Now if you go for this ratio, because here it has been asked about ratio, so your ratio will be V by V naught, V by V naught. This will be equal to V, I have already calculated here, V is your, this one is V, so this will be root over GL sine theta by root over GL 3 sine theta, C sine theta plus 2. So this comes out to be, this is equal to sine theta sine theta by 3 sine theta, this is theta. This comes out to be sine theta plus 2. So to the whole power 1 by 2. So this is your answer. Now I am going to the fourth question. This was your fourth question. Now I am going to the fifth question. Here this is your fifth question. And now here fifth question. This is also not a tough question, but it is also on. You have to find the impulse. So when the ball is dropped, when the ball drops, then your final velocity. This is final velocity. V square will be equal to 2gh, your v square. So v will be equal to 2 into 9.8, and it falls through 40 meter. So this comes out to be 28 meter per second. And after collision, what happens? That is the gain in kinetic energy is equal to the, this is your loss in, because of this, the gain in kinetic, after collision, because the gain in kinetic energy, here that is the gain in kinetic energy will be equal to loss in potential energy. Gain in kinetic energy will be loss in potential energy. So here 1 minute, here this is some here this is gain in potential energy, not kinetic energy. Gain in potential energy, because the ball, after striking the floor, it rises to a height of 10 meters. So there is gain in potential energy, and this is loss in kinetic energy. So this is, here there is loss in kinetic energy. This is loss in kinetic energy. So your gain in potential energy, that is mgh, and this is equal to loss in kinetic energy, that is half mv square. So here your this is gain in kinetic, this is the loss in kinetic energy. So here you that is 9 point mass, your mass cancel out, 9.8 into h, that is 10 1 meter, 10, and here 2, this is into 2, this is equal to v square. So this comes out to 14 meter per second, that is equal to, this is the velocity, this is the velocity after collision. This is the velocity after collision. So so your impulse, that is impulse, f impulse, this is ft, that is equal to m v minus u. This is your impulse. So m is your 0.5 and v is your 28 minus 14. So this comes out to be is equal to 7 Newton second. So this is your answer. Because when the ball drops, then just before striking, your velocity will be this one, and velocity this one, and after that is after striking the ball, after hitting the ball, then there is gain in potential energy, but there is loss in kinetic energy. So after collision, your velocity will be this one. This is your velocity after collision. So your impulse, that is m v minus u, that is 28 minus 14, that is 7 Newton second. Now Newton second. Now I'm going to your this sixth question. I'm going to the sixth. Here this sixth question. Yes, in the sixth question, here you see the plates of a parallel plate capacitors. are separated by distance d, two slabs of different dielectric constant, thickness this and this given. So what happens, there within three capacitors are created and they are in series. So your capacitor C1, if you take K1 as your dielectric constant, so your capacitance is C1 that will be equal to K1 epsilon naught A by, that is distance is 3 by A d, this is your distance, and we are taking C2, that is equal to K2 epsilon naught A by, that is d by 2, and your third, that is third third, that is C3, this will be equal to epsilon naught A by d by 8. Now here again one thing it is given to you, that is the equivalent capacitance, that is C dash. One thing this is given to you, that is the equivalent capacitance is equal to C dash is equal to 2C. And this is given to you. Here you can see that the capacitance becomes 2 times larger than the larger. So your equivalent capacitance is 2 times the original capacitance. So because they all are in series, so your equivalent capacitance will be 1 by C dash. This will be equal to 1 by C1 plus 1 by C2 plus 1 by C3. Now if you place this value and if you calculate this C dash, place this value, and if you calculate C dash, you place this value, and when you calculate C dash, it comes out to be equal to, that is epsilon naught A by D bracket, that is 40 K2 by 32 plus 5 K2. Now one thing is here that a relation is given between K1 and K2. We have to put this relation. After putting this relation, you are going to get this is the equivalent capacitance, and again here it is given to you that C dash is equal to 2C. Now you place this value of C dash here. When you place this value of C dash here and C C dash here, that is C dash, I am placing this value. See epsilon, when I place this value, epsilon naught A by D bracket 40 K2 divided by 32 plus 5 K2. I am placing this value. This is close, and this is equal to 2 times epsilon naught A by D. This was your original capacitance. Now if you solve this, you are going to get K2 is equal to 2.13. You are going to get K2 is equal to 2.13. Now I am moving to this question number 7. Here a question number 7. Here you see that a wire of resistance R is cut into 8 equal pieces. From these pieces, 2 equivalent resistance are made by adding 4 of this together. In 4 of this together, it is cut into 8 pieces. So the resistance of each piece will be 8, and 4 resistance are in series. This is the resistance of each piece. Now if we find the equivalent resistance of these 4 resistance, we are going to get, that is we are going to get 32 by R, and so here this is R dash equivalent resistance. So R dash is equal to R by 32. Now these 2 resistance are connected in series. So your final resistance, this is your final resistance will be R dash plus R dash. This will be a final resistance. So this comes out to be R by 32 plus R by 32, and this is equal to r by 16. So this is your answer. This is your answer. Now I am moving to question number 8. Question number 8. Now here question number 8, you have to find a particle of mass m, and it is moving with is moving around the origin with a constant force F pulling towards the origin. So here we are going to use the Bohr's model, that is angular momentum is conserved, that is m sorry that is mvr, that is equal to nh by 2 pi. This is your, and from here we are going to find out and we know that the centripetal force and F is equal to mv square by r. So here r is equal to nh by nh r will be from, let me take one more. Remove this. From here we are going to take r. R is equal to mv square by f. This is your r. Your r. We are going to do one thing, that is here we are going to place the value of r here. When we place the value of r here, this will be mv square by f is equal to nh. This is the Planck's constant, 2 pi, you all know that. So here you get that v square, that will be equal to m square v cube by f, that is equal to nh by 2 pi. You are going to get this. From here you are going to get a relation between v and n, which we require it. From here we are going to get that is v cube is proportional to n, so v is proportional to n to the power of 1 by 3. Again here we know that r is proportional to v square. So from these two relation we are going to get r is proportional to n to the power of 2 by 3. So this and this is your answer. Now I am going to question number 8. Then I am going to question number this 9. Here question number 9. Again here you see a body of 48 Newton on the surface of the earth. The gravitational force experienced by the body due to the earth at a height equal to 1/3 of the radius of the earth from its surface is. You have to find the gravitational force, and you know the gravitational force, that is F is equal to g m, this is the mass of the earth, by r square, this is the radius, and this is equal to it is given to you, that is force, that is 48 Newton, it is given to you. Now we have to find the force gravitational when the body is at the height of 1/3 of this radius. So here your F1, that will be equal to g m, this m by r plus r by 3 the whole square, this is come to whole square, and this will be equal to g m by 4 r by 3 the whole square. This will be this one. So if you place the value of here, you see that one thing, if you see here what you are going to get, g m by this is 16 r square, and here this is 9. The value of this, here you see the value of this, the value of this is 48. So 48 into 9 by 16, you are going to get, this is 27 Newton. So this is your answer. Now I am going to the another question, that is uh, now here the second question. So the second question is a photon and an electron having the same energy, and their ratio is given. Their de Broglie wavelength is, we have to find the de Broglie wavelength. De Broglie. Now here we know that your lambda, that is the wavelength of electron, we know that wavelength of electron, that is equal to h by root over 2m e. We know this. Now, and again we also know this lambda of photon, that is equal to hc by e. Now we are going to divide it because we need the ratio. So lambda photon divided by lambda electron. This will be, when we divide it in these two, we are going to get c root over 2me by e, and your final result will be c root over 2m. Your final result will be 2me. So now I am going to the second question, another question. Your another question is here. In some this you have to find the acceleration. So you have to find the acceleration. So here you see that you see that it is t is equal to x square plus x. It is given to you. Now I am going to differentiate it with respect to t when I am going to, that is dt by dt, that is equal to 2x dx by dt, and plus dx by dt. So here 1 is equal to 2x common, sorry. Here this will be 2x plus 1 close dx by dt. Now again this will be 1 by 2x plus 1, that is equal to dx by dt. Now second differentiation, when I do the second differentiation, it will be minus 2 by 2x plus 1 the whole square into dx by dt is equal to d2x by dt square. Now I am going to place the value of dx by dt here. When I place the value of dx by dt here, that is minus 2 by 2x plus 1 the whole square, and dx by dt, that is 1 by 2x plus 1. So this comes out to be minus 2 by 2x plus 1 the whole cube, and this is equal to d2x by dt square. So this is your answer. Now I am going to this next question. Your next question is microscope. So you have to find the magnification. So your formula here is magnification m, that is equal to minus L by f naught into d by fe. So focal length of the object, focal length of the eyepiece. So here this will be equal to minus 40, and focal length of the object which is given to you, that is divided by 2, and the distance of distinct vision that is given to you, that is 25 by 4, and this comes out to be minus 100. This comes out to be minus 100. Now my next question is here. Next question. This is also an easy question, not such a tough question. My next question. So here, this will be 2K 3T temperature difference, source and the sink, T1 by distance between them. This is X because they are equally spaced, and this is equal to K T1 minus T2 by X, and this is equal to 2K T2 minus T by this is X, and this is also X. Now if you calculate this, you are going to get, when you calculate this, you will get here, this is the relation we are going to get, 6T minus 2T1, this will be equal to T1 minus T2, and this is equal to 2T2 minus 2T. You are going to get this relation. Now I am taking first and second. From first and second, from this and this, first and second, 6T minus 2T1 is equal to T1 minus T2. Now from this we get a relation that is minus 3T1 plus T2 is equal to minus 6T. This is your equation 1. And again I am going to take second and third. If I take second and third, T1 minus T2, that will be equal to 2K T2 minus T by X this will be 1. If you take this second and third, 1 minute, second and third, second and third, if you are taking second and third, you are going to get third, that is 2, and I have to remove this before writing 2T this. From here we get a relation that is T1 minus 3T2 is equal to minus 2T. We are going to get this second equation, and here this first equation, second equation, and by elimination method, if we solve this first and second equation by elimination method, this 2, when we solve it, that is we want the relation between actually want the relation between T1 and T2. So T1 and T, you have to eliminate this this T. When we eliminate this T, we have to eliminate this T. When we eliminate this T, we get this is the relation we are going to get, minus 3T1 plus T2 3T1 plus T2, that is equal to 3T1 minus 9T2, and this will be further will be minus 6T1, that is equal to minus 10T2, and from here we get the ratio we are going to get T1 by T2, that is equal to 5 by 3. We are going to get this relation. Now I am going to the second question. Now my second question is here making a 60 degree with the vertical. It is making 60 degree with the vertical. So the figure comes out a uniform rod of mass 20 kg of length 5 meter leans against a vertical wall. So it will be a right angle triangle. The figure will be somewhat figure will be somewhat like this, and then it will be somewhat right angle triangle, a right angle triangle. Now here it is, this is 5 meter, the length of this rod is 5 meter, uniform rod is 5 meter, it is leaning against a wall. So here we are going to get a force, this is the force acting in this direction, let this be F1, we are getting a force F1 in this direction, and the weight is acting at the center of the mass, it is vertically downward, and this is mg weight. So it is making an angle theta here, it is making a 60 degree, so this will be 30 degree, this will be 30 degree. Now we are going to find the torque, that is A, B, this is B, and this is C. Now we are going to find the torque. So your torque will be about this point A, we are going to find the torque about this point A. This is your A. Now we are going to find torque about this A. So this will be F1 into BC, F1 into BC, that is equal to weight W into this point is E, this point is E, so W into AE, this will be AE. So here this F1 force will be the frictional force, here your F1 force will be the frictional force. So now your F1 BC is 5 cos 60 degree, 5 cos 60 BC will be 5 cos 60 degree BC or BC, or this is BC will be 5 say sine, you can take a cos 60 degree, cos 60 degree, and the weight, this weight is how much? Weight is 20 kg, so this will be 20, and G it has given to you 10, and your AE will be 2.5 sine 30 degree. AE will be sine 30 degree. So here your F1 into 5 cos 60 degree, that means 5 by 2, and 20, this will be 20 200 into 20 into 10, 20 into 10 into 2.5, and this will be 1 by 2. Here there is some mistake, that is your BC and AE force because here this will be BC, that is BC, this is 5 cos 60 degree, this is BC, that is equal to W, and AE, your AE this will be cos 30 degree. AE, that will be 2.5. This is 2.5 cos 30 degree. So here 5 into 1 by 2, this will be weight, that is 20 into 10 into 2.5, and cos 30 degree, that is equal to root 3 by 2. This is your cos. So from here your F1 will be, this is equal to 20 into 10 into 2.5 into root 3 by 2 by, here this will be 5. 2 one thing, this 2 cancels out, this 2 will be cancel out. So here this will be by 5, 5 4s are 20. So this comes out to be 40 into 2.5. 40 into 2.5, this will be 100. This will be 100 root 3 Newton. This is your answer. We have to find the torque. Here we have to find about this moment of a force, and your frictional force. This frictional force F1 will be your frictional force. This is the F1. This is the force exerted by the wall on the leather. So on this uniform rod. So this will be the frictional force F1. Now I am moving to another question. So here you have to find the amplitude. So two springs I suspended from two separate mass here oscillate vertically if their maximum speed are same. Your maximum speed is same. So your maximum speed is same, therefore your half k1 a naught square, that is equal to half k2 this is a point mass P and Q. Let this will be AQ, and this is AQ, and K2, this will be AP square. So from here we get that your AQ square by AP square, that is equal to K2 by K1, and so AQ by AP, that is equal to root over, this will be equal to root over K2 by K1. So this is your answer.